Hello everyone, it is August 6, 2024, and this is the bi-weekly libhal meeting. All right, we have a couple of things to go over, some things on the can opener. The can opener is working, we have a working product, it is doing the thing, we're pretty happy with it. We also have we now have like an ST32, we have an STM32 loader that works on Chrome and basically Chromium. Anything that supports Web Serial, we now support it. Web Serial seems to be supported on Windows for Opera GX. Does not seem to work on Mac. We don't know if it works on Linux yet. But this is really amazing because this means that we're planning on adding in by probably tomorrow or sometime by the end of this week, maybe next week if we get busy with some other things. But we'll have a button that allows you just to press it, and it will basically you connect your device and then you press upgrade, and it'll do the work of flashing your device up to the latest version of CanOpener or latest that we have put onto the CanOpener website. So you don't actually have to worry about using libhal or downloading ST32 loader and like that. The website will do all the loading for you, and this is the kind of experience that we want our users to have. We want people to be able to use our tools, not have to worry about having the factory flash them at all, plug them into the computer, connect them, press go, and then have the whole thing just flash for them. No more do we need to get specialized software to do all this crap. No. BS. That sucks. That's annoying. If your browser has an app that you're using, just let that app flash your device for you. So that's what we're doing with CanOpener, and it's working out quite well. Another thing that I want to go over is the exception performance updates. I thought it'd be fun just to bring this up. I've been kind of keeping it more secretive from the libhal videos, but I think it's just nice to talk about. So here we're going to go over some of the performance that we've been working on. So I'm going to describe what this table is. It's a little complicated. Here we have group number. Don't worry about that. It's just how I individually make each one of these things unique. Let's look at group number 0 though, which is, imagine that you have some code where you're going to, it's going to go 6 layers deep. And then at that 6th layer, it detects an error and it's going to return that error up 6 layers. The function ratio to detour, the detour ratio here is the percentage of functions in the sequence that has a destructor. So in this case, all of these have no destructors calls. If you were to try to propagate that error using 4 bytes as an error code, then it would cost you around about 556 cycles to go up the stack up to your handling function. If you use normal built-in exceptions, it would be 15,000 cycles. That correlates to around about, that results in about 27.6 times slower than just returning up a number or a 4-byte number. Now in comparison, and actually this is not just 4-byte number, I should be a little more specific here. I think this might be a little disingenuous. It's still expected, where the error type is 4 bytes and the value type is also 4 bytes. That's a little better to look at. Where we're at currently is we went from the best case, I think 21% here. Yeah, 21, or actually something better. 21.9, 20. Where's the 21.5? Oh, right here. Cool. Perfect. So relative to the built-in exceptions from GCC, my implementation so far is between 2.5 or 2.6 and 5 times slower than returning up a state expected 4 bytes to 4 bytes. So that's a reduction in cycles of 88% against GCC, and reduction of cycles by 82.72% relative to the worst case for GCC. So that's where we're at right now. I think that the results are pretty great in my opinion. The thing that's going to bring us to the next level though is the fact that I have these numbers here, but they're not technically consistent. The issue with this number is that this number really depends on the number of functions your code has. The more functions your code has, this function gets worse. And that's because of the binary search. The binary search we do in exception handling, although it's a great way to divide and conquer and to get your number, it works, and it works extremely well. It does increase the number of cycles you have depending on the number of elements you have to get through. we're working on a way to get rid of that so that it's just simply a O of 1 operation. It's still table-based exceptions, so that all kind of stays the same. There is no ABI break so much. Actually, there's no ABI break in what we're doing at all, because you could still use the old exception unwinding mechanism with how we reorder all of the functions. So that's actually, I think it's considered forward compatible. I forget. But basically what we're building up is not, it will not break even older code using the old runtimes, which is great. I think that's an amazing little thing there. But I think the number of cycles here is, I think I told one of the people who's working with me a different number. I said 140. Let's do 100. Let's do 140. Screw it. So 140 is the number of cycles it takes to binary search your index table if you have, I think it was like 550 functions. With that number of functions, it's about 140 cycles to do the binary search for it. I think I've optimized it as down as I possibly can, but there might be some better optimizations I can do. Now, if we multiply this by 6, and let's assume that this was the same number of functions, it's not, but let's assume it is. If we could somehow subtract away all that time, or most of that time, let's just do most, let's say we only use 20 cycles, really, we would be able to get from 87.72 to 82.7 to 87.4. So that's a pretty good improvement, and it moves us from 4.7 times to 4.5 times, 3.5 times, which I think is pretty good. It gets even better though when you go down to things like this, where we have 96 functions in depth, and then here we can do 96 times 140. Again, this is like assuming we have 0 time we need in order to do the index search. This actually does such a great job of reducing the cycle count that it's actually very close to what expected. This probably isn't true, but this does get us to this 95% mark that I've been talking about before. I think what's most likely to be the case would be something closer to, let's say 140. Let's say whatever we do takes up 60 cycles. So it would be 80 times 96. Yeah, nearly 1.5, which to me, I think being 1.5 times worse than stood expected in some cases, I think is and between that and potentially 3.47, I think that's a pretty good range. I think that would be good enough for most people to accept using exceptions, because you still get the benefit on the happy path. So that's all to kind of show you the progress that's going on here. And yeah, so that's what's happening on the exception performance side. All right, so let's get into libhal fully realized. Me, Denise, and Malia are working together to kind of come up with what would libhal look like when we what does the finished libhal look like to some degree. Now, I don't ever believe that libhal will ever be really finished. None of these individual packages will ever be finished. But what does a fully realized libhal look like now, given what we're looking for? And I want to start from the bottom and go up. First off, I want to say that the core and foundation of everything that we're doing in libhal is composed of, obviously, our compilers, our tools that we use to compile our stuff, building packages to make it easier for developers to use libhal or to just build in Conan in general for embedded systems. There also is the libhal core interfaces. These are the interfaces for output pin, input pin, interrupt pin, PWM, ADC, I2C, SPI, serial, etc., etc., etc. All of that is there, and that's the foundation of the contract that libhal builds up, such that all other libraries can depend on those contracts and those semantics in order to do their work and allow their code to be portable. Lastly, we have the exception runtime that we're building. E just stands for Estelle. I just kind of put that there. Might change it to some other name in the future, but basically I'm just naming it after myself. But the main idea is that we use exceptions, and we're building our own exception runtime that gives us the performance that we're looking for. The users can also opt to not use this if they don't want. That's totally fine, but we'll provide it for people who obviously want to use it. This next layer is all the different platform libraries that we're going to build, and this goes into the next page, or the next topic, which is going over how we're going to reorganize. I'm going to go over a little portion of this. But basically, the maintenance, the way that I had designed everything before, to give some rationale, I designed all the libraries or the repos in such a way that if the major number changed for them, it wouldn't be a catastrophically large change for a lot of code. This was really important for libhal itself because if I had the utilities in there and I broke a utility on accident, or on accident, sorry, I broke a utility on purpose and it was small, then the entire foundation of libhal has to then break its version number. And now people have to then question, was the change something that matters to me or does it not matter to me? And that requires an investigation. That's a lot of effort. So I wanted to spread things out. That's why libhal LPC existed. That's why LPC STM32F1 existed. All these other platform libraries that are separate from each other. I wanted to make sure that if LPC had a breaking change or something like that, that it wouldn't affect STM developers. The problem, though, is that even if I just did that, I still had to go through all the repos and change things around anyway. It didn't actually make my life any easier. If anything, it made my life a little harder. I didn't really get the benefits as a maintainer, and I doubt my users who have to maintain their own code will get those benefits. So, yeah, I realized, you know what, we should just put code together that makes sense going together. So ARM-MCU package will be in there. So ARM-MCU package is all of the ARM packages. For anything that's an ARM-MCU, it goes in there. Same thing with 5, same thing with Linux, same thing with ESP. At some point in the future, I will probably acquiesce and will support ESP. I do not like ESP. Let me take that back. I actually do like their technology. I didn't like a lot of their earlier devices because they had a lot of problems. I don't like that their code has a lot of, what's what I'm looking for? Binary blobs that are not open source. I find that to be one of my biggest gripes with ESP. They also didn't have their user manuals available for the longest time. So there's a lot of different things that kind of just made me less enthusiastic to jump onto ESP so early. Anyway, AVR would be another one. I think that in the libhal fully realized, having AVR supported is two things. One, it then brings like most of the class of Arduino stuff onto our side. ARM is most Arduino, I'd say, at this point. RISC-V is another extension to that, but it's kind of minor. AVR would kind of piece it together, but also we would simply do this just for the bragging rights and for the flex that it would be. Because I think most people don't believe that exceptions can work on AVR, or most, like an 8-bit system like this. And Shin, one of the EE lead from robotics, he actually proved it, that he was able to make it work. So yeah. Now to work on real hardware too, so it's not like it just we just got to work on a simulator or something like that. On top of here, we have display package, actuator package, storage, sensors. This should be sensor, input, IoT, expander, and then board and RTOS packages. From display to expander, these are all device libraries that we will. These are all device libraries that will just be categories for the most part. I'll go into a little more detail about them later on, but basically, any and all things that have to do with display go into display package. Anything that is a motor, such as a stepper motor or a DC brush motor or a BLDC motor, will go into actuator, and so on and so forth. So now when users or developers or contributors are asking me, actually all of them can be asking this, where's my stuff? I was like, well, look at these categories and tell me which one of these kind of fits what you need. If it is, it's probably in there. If it's not in there, then we don't have it yet. If you're working on something like a stepper motor driver or a brush motor driver or something along those lines, you'd put it inside of actuator, and so on and so forth. And you don't have to wait for me to make a library for you like we had to do before. So that's kind of like the first tier of libhal. It's kind of the core and the root and the foundation of everything else here. Without these things, nothing else here would really matter. I mean, I guess it would. I guess that's not exactly true, but to some degree it is. Next up, we have developer resources and testing. This will include things like us doing hardware testing. And this is the hardware testing part here isn't saying that like we're providing hardware testing as a service to the people. That's what this one is to some degree. But it is that I firmly believe that actually, yeah, I really can't stand trying to write unit tests for hardware. My biggest gripe with it is that I have to basically simulate hardware in code. And I might have explained this before, but basically trying to write a unit test that reflects the behavior of a device is actually quite complicated. I've done it multiple times before. It has worked out reasonably well. The problem is that when you make a bad assumption about how the device behaves in certain cases, so your tests can be completely fine, and but it doesn't reflect the behavior of the actual device. And I think that it's really important that we figure out a solution to doing testing on hardware, on real hardware, and integrate that into CI. Because without that, I think that like none of our tests really matter. And I think any sort of test coverage we have is less. Let's put it like this: I removed all of the coverage stuff from all the libraries purely because I realized that it was a bad number. It just didn't help you with anything. There are certain things that had a lot of coverage, but just because it had a lot of coverage doesn't mean that the actual library will actually work. It actually gives you no bearings on that because it would require that the test simulate the hardware well enough. And I've had that be a mistake many a times. So yeah, actual hardware in the loop is really important. Next up, we have GitHub workflows, basically making sure that people who utilize libhal in their own projects, in their own repos, are able to utilize all of the CI stuff that we are currently using in libhal itself. I don't think there's any reason for us to not make the things that we're currently using available for others, because I think the amount of effort required is not that much. Next up, we have sclang. This is our improved. It is our own development stack for C++. It's LLVM plus Conan plus CMake, or actually, which comes from Conan. Plus, we also turn on a whole set of flags for you that are meant to give you as much safety as possible. I don't remember if LLVM has the static analyzer flag that GCC has, but we'd be turning that on. We would turn on every single thing we can, and we'd also turn on Clang Tidy. Clang Tidy was able to identify, and I think I've seen this before. Clang D showed it too, which is great, which comes from Clang Tidy for the most part. I think it's coming from the same place, but was able to identify that like I had a static variable that was going out of scope, and I think it was able to identify that like actually I need to check this, but basically Clang Tidy was able to identify some bugs in my code before I ran my code, and I already knew that they were there. It's just kind of nice to see that it was trying to alert me to that before I made a mistake, which is great. On top of this too, we have testing hardware kits. So on top of, I'm going to just jump over here real quick. We have developer hardware kits. The idea would be that if a developer wants to just get started with libhal, a lot of times I've found that like, and this is me too. If someone says, hey, I have some hardware, what can I use? Or we have this firmware framework and stuff like that. I like to just get started with it. A lot of people will ask, what is the hardware you recommend that I use for this to get started? And the hardware that I'd probably recommend for people to use, honestly, will probably be, well, at the moment it's LPC40 because we have the most features for it, but we don't. They're kind of expensive to develop. We have the STM32F1 board, micromod board. That one's great, and that's actually one of the ones that we will promote. But we'll tell people that it's for like low. It's the cheap, low cost alternative with low resources, and it's a good platform to develop on. It's just you won't have a lot of resources to do stuff. I think the RP2040 is going to be our big killer app project device that you can use to do anything. So there will be that. Moving over to testing hardware kits, this is where we take whatever we're building for the hardware testing here and see if there's a way that we can scale it or not scale it, but make it such that it's usable by people and organizations outside of us. And this can go in two ways. One part is the hardware testing is used as, well, if some developers want to ensure that the code that we have upgraded, like let's say they want to upgrade libhal actuator to the next version, and they want to make sure that we didn't break any of them, and they don't, and let's say for some reason they don't trust that our hardware and our CI is doing the right thing, which could technically happen because if they're maybe working with the government, they want to maybe have their own way to test outside of what we tell them. Great, cool. So we give them the hardware kits and give them a guide on how to connect everything together. have it connected up to whatever system they have to do their CI, and then let them just do the thing. And they can use that in order to do all their testing. They could also potentially expand that to do testing for their own stuff if they want. So maybe having such kits and a standard for this could be useful. Next up, we have Exception Insight. This is the name that I've given to the project that Madeline's working on. We may change the name though. I want Madeline to be able to, get an opportunity to do branding and like think about how we can best brand and market. Give a name to this thing to give it a good, make people interested in it. So Exception Insight, the whole idea is that tool that we will build that will analyze your binary, evaluate all the places where you've thrown code, evaluate where all the catch blocks are, and then tell you if you've missed any, if you haven't caught specific exceptions. And it will tell you the stack trace of where those things happened. Or at least the potential stack traces where this can happen. That's pretty much that. Hopefully we can give other information like how much memory, the max memory that is used per thread. We can give, because information is knowable inside the binary. We could give other information such as the total number of types that you're throwing. Hopefully some way to visualize the exceptions and your call graph in such a way that you can actually see, oh, I have like 3 exceptions or 3 catch blocks here. They're catching the same type, and I have control over all this code. Then I go, oh wait, why keep all 3 of them individually, and then have to then like figure out how to like handle them individually? Where in reality, I don't want to handle them all the same way. Let me just extract out the catch block from all these other lower functions and put them at the top, something like that. Hardware analysis tools is another one here. The hardware analysis tools, I was looking on r/embedded, and one of the guys brought up something that was really interesting. He's like, if you're ever doing any development, you should definitely, make and or acquire an I2C, what's the word I'm looking for? An I2C glitcher. Basically, you can program it and set it up to glitch out the I2C bus in order to cause erroneous behavior, in order to see how your code behaves with it. And this would be a way to get some of the rare exceptions that almost never happen, such as like device not found. In general, if you found the device the first time on boot, it's probably going to be there forever unless there's some sort of hardware damage. Having it happen outside of that is usually exceedingly rare, but it could happen. And if you are in an environment where you think that might happen and you want to make sure your code can handle that, having such a thing would be helpful. So CanOpener is an example of a hardware analysis tool because you can analyze CAN messages. The I2C glitcher is another one because we really can't find it anywhere on the market. So at the very least, I would like that for my own testing. So I think we're going to probably develop one of those. And then anything else that we find might be useful. A part of us, we really do want to build our own ST-Link devices. I think that would be really awesome. I need to check to see if there's already ST-Links with USB-C and the 5x2 SWD connector. Because if there is, we'll just buy those and just use those. We don't have to make our own. But if there isn't, we're going to fill that part of the market because I hate having to use the other. I mean, I don't hate them. I think they're cheap and they're great, but they're just it's not as easy to work with. Then we have fast and fuzzy or fuzzy and fast API indexing. We already have this actually. When you go to the APIs to look up libhal APIs, you go to their API docs page. That's all there. This is just saying that this is like a fully realized libhal. We should have that for everything. So for all the different packages down here, excluding like compiler package and that kind of stuff, we should have the APIs available through some documentation page. Alrighty. Next up, we have educational resources. Online guides, we kind of like what we have now, except I would like to have way more of them. We currently only have like the basics to get started, but nothing really more beyond that. And the basics of libhal, but that's about it. So more online guides. I want to also have interactive tutorials. I would really, really, really love it if we had a web page where one half of it, it's kind of like W3 Schools where you have one half which is your code and the other half which is like a viewer. I would love to have some sort of like simulated hardware device on the right hand side. This is just HTML and JavaScript, but the C++ code is able to then invoke that somehow. Maybe we can somehow compile up the code in some web interface and then have it produce something. I don't know how we're going to go about doing that. Maybe we can use like Inscriptum and some other crazy stuff to kind of make that happen. I'm not sure. But I do love the idea of having that exist because I think providing a way to test without needing any hardware, just running on your machine, just kind of like get the feel for things, I think would be really cool and also really helpful for development and could become a kind of compiler explorer, except it'd be like libhal simulator. Basically, yeah, a libhal simulator would be great. That's pretty much what I'm asking for. On the side of books, the books that I would like to create to kind of represent libhal would basically just be a book that I would want one part of it to be introduction to computer architecture and like, just digital design, that kind of stuff. Very, very basics of that. Don't need to go into too much of it, but just enough to kind of give people the idea of what's happening. And then explain the libhal core and like the basic interfaces that you interact with. Then explain uh, 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 how peripheral drivers are kind of written up. And then explain how libhal code works with like displays and actuators and that kind of stuff and how all the different pieces come together. And then explain like how you could build this up, how you could expand this on your own, how you can develop this outside of what we have in our own ecosystem and that kind of thing. Basically a book to kind of be a introduction to embedded systems and computer architecture, like the minimal amount for firmware, and also a way to utilize libhal in order to achieve the goal of building up a product. Maybe it'd be multiple books, but like that's kind of the idea. And then at some point I'll make a book on exception handling and like how it works, just because yeah, there's not much of that out there, and I think my approach is very different and very and it's obviously kind of different because it's giving better results. Marketplace. Let's see how much time we have left. Cool. We're only about 30 minutes through, but I'll try not to take up too much more time. We're almost done with this. Marketplace. So, one of the things, let's go over to what the marketplace is. Marketplace is just a place where where users can place their open source or closed source libraries and place them onto this open market or this open marketplace, and developers can who want to use it can download it. And if it's a proprietary program, they can still download it and use it if you want to make it free for people, just not give them the source code. Or we could also potentially have a way for people to purchase a license to utilize that software. I find that one of the things that I found that at Google, we had companies that we worked with that were building up algorithms and code that we would then use and put into our products. And I have no idea how they found these people. To be frank, I legitimately don't know how we found some of the organizations and groups and that kind of stuff. It could have been like a person who knew a person who knew a person, or it could be from other projects and they kind of got handed over to us. I don't know. And to be honest, I just find that doesn't exist anywhere. I would like there to be something like Python pip or NPN, but for firmware drivers, and in a way where OEMs or other companies, or maybe not OEMs, I don't know how I feel about them doing this, but other companies that want to sell their software as a product that they sell, I feel like there aren't enough places online where you can do that, where you can buy digital assets for firmware. You can do that for 3D games, for game models, which makes sense. Those are very complicated, time-consuming things to build. But basically, I want at some point there to be asset flips of like an IoT toaster. The first part someone builds is like build an IoT toaster. Well, maybe not toaster. Those are kind of dangerous, but like IoT something or other. It doesn't really matter. But basically, that's a thing. So that's the marketplace, a place where you can find all your different packages. You can find packages built from the community. You can find packages that are verified by libhal directly. Think of it kind of like Amazon Prime in a way. We have ones that we vouch for and say, hey, these ones that we trust. We have hardware testing to ensure that they operate in a way that they should. That kind of stuff. Potentially a bounty program. This is actually kind of up in the air. I don't know if we're really going to stick with this, but maybe that's something that people find is like, hey, if someone can build, I will pay $500 for someone to build a library that fits these specifications. And then finally, Llama, I've been playing around with it a little bit. It's a large language model. I think it's pretty nifty. It lies a lot. It lies a lot. It just makes up stuff all the time. But I think that if we can confine it to just our libraries and our ecosystem of stuff, we could probably just have a simple project composer. Really, all you're doing is asking it, saying, hey, I have a project of this specification that I kind of want to build up. What type of library should I use? And can you give me some like starter code? and can try to give it some decent starter code, and the person can kind of go from there. And then we can try to train it to say, hey, these are all suggestions. Make sure you talk to, libhal people to get a better idea of if this will actually, work. Yeah, that's another option. And then finally, we have support. This is one of the things that I want libhal, when it's fully realized, to really have. If it does not have this, then there's no way for, I think, libhal to be sustainable. If there's no way for people to get support for the problems that they have with it. So number one is the Discord community. Simply, people come to the Discord, and if they have any questions, if you're interested, you can help them out. But that goes only so far. If a particular company is using us and really, really wants to, get a lot of help from our community, rather than making people give them help for free, they could work with us. We could basically do consultation. And this is where libhal kind of goes from like just an open source project to more of a actual like business. And I won't go too much into this here, but for the most part, I think that it is possible to run a business on open source. The people who be employees of that would just be people who've part of the community who are interested in the project enough for us to actually hire, so long as we have the funding to hire such people. And those people would be our first line of defense in terms of if anyone needs help and support. Basically, kind of like Conan. Conan's an open source project, and they're funded by JFrog, and they're able to, I think, do a really good job of supporting, even on the Slack. I think they do a good job of supporting people who need help and their whole ecosystem with the people they have with them. And I was gonna say one more thing about. Oh yeah, I remember. So there's one last thing about libhal that I didn't really mention here, but it's I forget who I was talking to, but I was speaking with someone, and they brought up the idea of what happens if some company is like, hey, you're really awesome, you're really great. What if we just buy you? Why don't we just have you internal, and then you can just be like our little internal project, and externally, we can continue to be open source and contribute to everyone else. And I thought that's, at first I was like, yeah, it's not a bad idea. But getting acquired and then, being full time at some other company that works with us doesn't seem too bad. It's too bad of an idea. But I did think about this. There is one big concern, which is that I've noticed with things like, and I've only looked at it a little bit, so I can't say much, but FreeRTOS, that got acquired by AWS. The normal FreeRTOS is exactly the same, no real differences. But Amazon did, in fact, Amazonify it. They made FreeRTOS built a little bit more towards their use cases. And that's not exactly a bad thing. It might have even been a good thing to some degree. But I didn't like the fact that there would then be a singular company that makes or breaks what libhal is. And I honestly just don't want libhal to be a trash project because we get bought by a company or get acquired by a company, do open source through them, and then they want us to bend our back and break ourselves in order to fit what they need. And I've observed this in the past. I'm in other situations, so I want to make sure we don't really do that. So my big thing when it comes to libhal is that it stays its own thing and is never really like React or other projects where it's a project from a big company that's funding an open source project. Yeah. So that's libhal fully realized, kind of from top to bottom. Next up, we're just going to go over the last little bits of the libhal package organization, and then we'll be good to go for tonight. So libhal ARM MCU is a package I've actually already made. I combined together ARM Cortex, LPC40, STM32F1, STM32F411, which is actually just 4 right now, but it's just 411. And then soon we'll have libhal RP2040. And then anything else, any other MCUs that are ARM-based will go into this repository as well. Actuator has already been made as well, and that includes libhal RMD and libhal soft for the RC servo. I'll keep RC servo in soft. I'll deprecate it, or at least I'll try to remember to deprecate it. And then the one that you're going to want to use is going to be the one in libhal actuator. This little diagram on the right represents the package organization between different packages and what their dependencies are. So L0 L0 means that there's no dependencies on anything, so there's nothing down here. They don't depend on anything. Compiler just depends on its compiler. Technically, exception runtime depends on libhal util, but I might extract that part. L1 requires libhal, so does mock, so does canwriter. So that's like everything else that just inherits libhal or requires libhal. L2 are things that L2 can basically inherit from L1 or can use L1 and down, but anything that's L1 cannot use anything that's above it. The reason why is because you could end up getting circular dependencies. So soft, RTOS, expander, and storage will be above these. Board libraries are allowed to basically, actually I should make board libraries L4 just because they can include anything below them, but I don't think there's ever going to be a case where, yeah, that should be an L4. Yeah, board library should be on the top just because they can technically include things like display, actuator, and that kind of stuff if your board has those things it wants to include. So in a way, board is almost always the topmost, and the only thing that goes above board would be application. The application would, obviously, your board would never include an application, I don't think. Well, that doesn't make sense to me. And your application is always going to be the topmost consumer. It's always going to be the top of the pyramid. And yeah, that's pretty much it for this week's libhal. Yeah.